Okay, so let's get started. We will do the lesson in English as usual, and our topic today is the new OpenAI API. I'm not sure if some of you had in the past already contact with the existing OpenAI API. It has been around for quite a while, and this API is currently reworked quite a bit. Let me show you the website so I can introduce you to the existing concept and to the new concepts. If we Google for OpenAI REST API, we will get to the documentation of OpenAI, and here you see the API reference. On the top left of the screen you see the menu, and here you see the old, or let's say the existing chat API. This is the API that has been around for approximately a year, and many of the applications that you see on the internet, besides OpenAI itself, are using exactly that API. If you want to use this API, you typically do not directly interact with the REST API. As you can see here, it is quite a lot of data, so you need to set up the REST API requests yourself. That's quite tedious. So typically you use an API package depending on the programming language that you use. So if you use .NET, for instance, we can say OpenAI Azure NuGet, and that will probably bring us exactly to the library azure.ai.openai. That is the current release of the API for .NET that makes it much easier to interact with OpenAI. Please note that this library is currently also in beta version, so it's not for general availability in production applications. There are APIs for Python, for Node.js, for Go, and many other platforms. Some of them are maintained by OpenAI and or Microsoft, and some of them, like for instance the Go API, which I already tried in the past, is maintained by community developers. So these are community libraries. Okay? So if we would just use the existing production API of OpenAI, we would exactly use this NuGet package. But this is, as we are here at an education facility, this is kind of boring, and therefore we will immediately scroll down and take a look at the new API, at a new beta API. This beta API was announced, I think, 3 weeks ago or something like this at the developer conference of OpenAI, and this is exactly what we are going to use. Now, what is the big difference between the new beta API and the existing API? Well, the first and most important difference is that it's way more powerful and way more complicated. So by now, the existing production API, I think we would probably be able to cover the concepts of this API in an hour or something like this, and then we are done. The new API is way more, let's say, interesting. Now, what's the idea of the new API? It's the so-called assistance API. The idea is that you can create one or more assistants. An assistant, if we take a look at what an assistant is made of, is essentially a description, a name, and instructions. The instructions, that's the system prompt that we have already talked about. That's the text that tells ChatGPT how it should behave. You can tell it to be a tutor in a school, you can tell it to be a car salesman, you can tell it to be a flower shop assistant, you can tell it to talk to use a language for children, to use a scientific language, whatever. That's the instruction part. So you create this assistant, and in contrast to the existing API, the new API persists these settings. So they are stored. You do not need to have your own database where you store all these settings and you have to retransmit everything from the very first byte on in every request. So now they are storing data. You will get back an assistant ID. You will see this ID in a second. And later on, you can always refer to this assistant ID, and OpenAI will immediately know what you mean. So they have stored the instructions, for instance, for you. So we don't need a database. That's very good news. The second thing that we need to understand is that now ChatGPT has a Threads API. Threads like communication threads. Up until now, if you take a look at the production API, you always had to send the entire conversation from the very first message until the very last message to ChatGPT. So you had to store this conversation yourself. This is no longer necessary. You now can create persisted threads. These threads are stored by OpenAI. You will again get back a thread ID, and later on you can simply add new messages by referring to this thread ID. So again, they are taking a little bit of work away from us, and that's a good thing. However, the API is not the simplest one. The good news is that you are very well prepared when working with this API, because this API is a really nicely designed RESTful web API. So the design principles follow exactly what you have learned in this course. And you will immediately understand how the paths are separated, how the payloads work, and so on. You will see that's really not difficult. That's the Thread API. Now, when the user enters something through any kind of UI, you have to add messages to the threads. So if you take a look at the create message, then you will see that to create a message, you have to refer to a thread. So before you can say something to ChatGPT, you have to create the thread, and then you store the message into the thread. Got it? So you can have many, many different threads. If you have a website and you have a lot of users on this website, you would probably create a thread for each user. And when a user types something in, you send the message to exactly the thread related to the user. Got it? The good news again is you do not need to store a list of messages. That is done automatically by ChatGPT. However, now it gets a little bit complicated. If you post a message to a thread, ChatGPT does nothing. It remains passive. It just waits. This is where the so-called runs come in. The runs mean that you tell ChatGPT, hey ChatGPT, please read the entire message history of the thread and create a new response. It's a kind of batch job that you are starting here. You are telling the large language model of OpenAI, become active, read the messages and create a response. Okay? So this is what you do. You create the run. Here you see you can create a run, but this run will not immediately return the result. This is just a batch job. It runs in the background. So what you have to do is you have to continuously retrieve the run, and inside of the run you have a status, as you can see it here, and you have to ask, hey, what's the status? What's the status? What's the status? Until the status receives, or the status arrives at the completed state. When the run is in the completed state, you can then ask for the messages here of the thread, and you will find ChatGPT's response inside of the messages. Could you follow so far? Things get a little bit more tricky when we add function calling to the equation, but that is something that we will discuss a little bit later. First, we want to cover the basics. We want to create an assistant using the API. We want to create threads using the API. We want to send a message, and we want to trigger a run and receive the message response from OpenAI. So let's cover the basics first, and then we deal with the complicated stuff using function calling and things like that. Could you follow so far? Okay, very good. If you want to learn more, I highly recommend to first take a close look at the different REST API endpoints. And then there is a dedicated guide here. If you take a look at the documentation, you see a lot of stuff here. It's very well documented. That's the production API, not interested for us today. We want to work with this stuff, and this is exactly the beta part. The beta API is, well, it's documented, but it's not very well documented. So there is a lot of room for interpretation, but this is why you have me. I prepared a sample. Let's see how it goes, okay? But be prepared. We have to create a lot of manual work, and hopefully in the next few weeks, months, the APIs will catch up, and then you can use the NuGet packages. But as of today, you have to use the REST API. Good? Nice. Now it's very important to understand when you want to play with this stuff that there is an assistance playground. This assistance playground is super useful. Let me log in for a second so I can show it to you. By the way, for this lecture I will give you an API key so you can follow along. So hopefully it will work. As you can see here, this playground, I will make it a little bit larger so you can see it better. This playground allows us to experiment with the API through a user interface. First, as you can see here, we can create assistants. See that one? So let's try that and let's take a look at the API so we really understand what the APIs do, and then we go into coding. So let's create an assistant, give it first a name. Let's say that's the Simpsons assistant. You are a helpful assistant answering questions about the Simpsons. Only answer questions about the Simpsons. If the user asks questions about anything else, say can't answer that. Okay, let's try that. The assistant is related to a modal. We can choose between different modals. The most important selection criteria is here whether you want to use GPT-3.5 or GPT-4. GPT-3.5 is cheaper and faster. GPT-4 is more intelligent but slower and more expensive in real life. So if you build an API and you want to put it on your website and you pay per API request, then you have to ask yourself, do I need intelligence? Then take GPT-4 and then you have to accept higher costs. Or can you work with 3.5? Then you get faster answers and cheaper API costs. Okay?
When does that really matter? Because in our case we just need 3.5, because it doesn't need a lot of.
And we will try exactly that, okay? So I will try it exactly here. Let's start with the 3.5 and then let's see how good it is, okay? Later on in our advanced example, we will add so-called tools. First, we can add function calls. That will be the topic of today. Hopefully, we will be fast enough to do that in today's series of lecture. Then there is the code interpreter tool. Are you all familiar with the code interpreter tool? Anybody not knowing what the code interpreter tool is? No? So let me show you what the code interpreter tool is. If we go to chat OpenAI and ask a question which forces ChatGPT to do some calculations, for instance. What could be something like this? We could say generate 100 persons with random names and random heights. Create a CSV file from it and allow me to download the resulting file. Something like this. Now take a look what's going to happen now. Do you see this analyzing? If I open that up, you will see that ChatGPT is now writing Python code on the fly, but it's not just writing this Python code, it's really also executing this code. So here you see it uses the pandas library from Python, the random library, it does some random stuff, and here you see it's going to take the pandas data frame and export it to CSV, and then it runs all this stuff and it gives me the CSV file as a download. I can open it up here and it opened up on the wrong monitor. Let me give it to you here. Yep, name and height. I did not specify what I want as the name, that this is a name of a person, so it generated just random blah, and then the height in meters, and that looks pretty okay. And code interpreter is the fact that the ChatGPT is capable of generating code and running it. Not just generating it, also running it. That's code interpreter. So if we want, we can allow the assistant to write code, execute it in order to answer the questions of the user. Got it? We will not do that today, but this is a very important and super convenient functionality. Retrieval means that we can upload files with data that the assistant is capable of using. For instance, we could take exports of our school's wiki, upload it here, and then ask questions about our school, and ChatGPT will take a look in these files, HTML files, PDF files, whatever, and answer the questions based on the information which is in these files. That would be the retrieval feature, okay? And then we, of course, have to use some files if we want. We don't need that one, and we will start very simple. So we can click on Save, and that saves the assistant. The assistant has been created. Now for us developers, this playground is super useful because there is a logs part here where we then, when we start with the threads, where we can take a look what's going on behind the scenes. So now we can ask questions with the GPT-3.5 Turbo. Does anybody have a suggestion for a question related to the comedy series The Simpsons? What is the name of the famous shop owner? Maybe it understands what I mean. Let's click on Run. And then we'll take a look at the APIs. It runs, and hopefully the famous shop owner in The Simpsons is, I will not try to read it, I just say Apu, who owns the Quickie Mart. That is correct. Now let's take a look at the logs. And here you see why this assistant playground is so useful. We can take a look at each and every web API requests. We see that the system first created the thread, then it adds a message, then it runs the thread, and then it continually asks the system for what's the status, what's the status, what's the status. Now if we take a look at the last status message and take a look at the response, we should see that the status here is now completed. That's perfect. That's exactly what we are looking for. So next is the system will ask for the messages. And inside of the messages, we see that we have two messages, and the first one, the first message, should be the answer. See? So we get a message history. Got it? And once we got this message here, the system will ask for the run, and I think that's it. There is nothing more, nothing interesting here anymore. So I think you got the point. Yeah, question.
What was the second message?
The second message was our message here as the user. What is the name of the famous shop owner? Got it? Okay, very good. So this was not a challenge for ChatGPT 3.5. Do you have a more elaborate question, a question that is harder to answer? So you see, as I said, for our application, 3.5 is perfectly fine. Do you see the value of this playground? As a developer, this is super, super useful when it comes to playing with the API, understanding the API. You save a lot of experimental time. You do not need to code every single request on your own. You can simply generate them and you get a deeper understanding what it does. Now, there are some severe limitations when it comes to the new API. For instance, let me go back here to my GPT-4 and ask a different question. Maybe we can ask the question, describe what classes are in C#. If you take a look at the answer, you will see that the answer is generated token by token. You see the tokens are flowing in. I will now stop the generation because it doesn't make sense to waste any compute time here. But you will see that tokens come in, they fly in step by step by step by step. This step-by-step generation of answers is called streaming. The existing production API supports streaming. It uses a protocol which is called server sent events. So the server can send events and you can get these events and you can process them. It's not difficult, especially if you use the existing NuGet package for C#. It really works like a charm. The problem with the new beta API is that they do not support streaming yet. OpenAI has communicated that this is a known limitation, and hopefully we will get a streaming API back at the beginning of 2024. But as of today, we cannot do streaming. So especially now that GPT-4 is pretty slow, not having streaming is kind of a big problem. Because you send a message and then you have to wait until GPT-4 has generated the entire message. Understand what I mean? And then you can display it. Well, you can get intermediate results, that's true, but you always have to poll the system. You have to poll the system, hey, give me the new response, give me the new response. Streaming is way more convenient, but that is currently not there. It will come, but we don't have to deal with streaming as of today. Got it? Good, nice. So with that, I think let's try to put all this stuff into a C# program. Good, let's get started. To keep things simple, to really be able to focus on what we want to learn today, I would like to implement a console app together with you. If you want, you can take the time as a homework to take what you have seen there and put it into an API project. But I want to get the noise to content ratio as good as possible, so let's remove the noise and let's really focus on what we want to achieve. Work with OpenAI. Still, you will learn a lot about web APIs because we will focus on the web client, the HTTP client. And I can tell you some tricks here. Good. I would like to ask you to create a new and empty project. So meaning an empty folder, and then you say .NET new console, and this is what we are going to do. I will do the same here on my computer. I hope everybody was able to generate a new console app. I did the same. I have a console app here on my screen. And we can do one thing before we go into the break. We need to deal with the OpenAI secret. You have to understand that the OpenAI API wants us to present a secret, an API key, in order to make sure, in order to identify the account that is currently working with the API. When using OpenAI in Azure, you don't need that. You have the so-called managed identity there. It's much more secure, but currently we need the OpenAI key. Now the question is, where can we put this key? We could create an app settings JSON file, but you shouldn't do that. Because when you take an app settings JSON file, you add the OpenAI key there, it happens very easily that you check in this app settings JSON file in GitHub. It might be in public repository, and immediately you have lost your OpenAI key and somebody can misuse it. Okay, so never do that. If you would like to maintain secrets in a C# application, you should always do that with .NET user secrets. I don't know if we have talked about that in the past. If we did, let's recap. If we didn't, well, that's something new. The first thing that you have to do in order to store some settings code secretly, you have to initialize the .NET user secrets in your project. So please say .NET user secrets init. This will create a GUID, here you see the GUID, in your CS_proj file. This GUID will be used to store the user secrets outside of the folder of the project. So .NET will automatically maintain a settings file outside of the folder. Therefore, if you check in the folder, the secrets will not accidentally spill into this checked in folder. Okay, this is what you do here. And then you can say .NET user secrets set, and we can, for instance, say OpenAI API key or something like this, and then we have to specify the key. For this lesson, I will give you the key in a second, but first I will show you how it works. Just say ASDF or whatever, and if you press enter, you will see that this is now saved to the secret store, but we do not have an app settings JSON in this folder. See it? That's the important thing. So if you need to store some credentials of a database or an API key or whatever, and you cannot use managed identity or things like that, please use user secrets. In the production environment, these user secrets can also come from environment variables, but generally for development, this is the way that you should do it. Did it work? Good. So I will now pause the recording and give you the OpenAI key, and I will delete this key after our lecture. Okay? Good. Welcome back from the break. Let's get started. Before we went into the break, we defined a user secret. And this user secret, as I told you, is stored in a different folder. You can look up the folder in the documentation. That's not the point. The point is that the secret is not inside of our folder, so we can check in this folder without any problems. Yes, you have a question? No, that's the same. You can use a .env file and then exclude this file from checking in. However, it can easily happen that you accidentally take this file and check it in. So using the user secrets is a little bit more secure because there is simply no file that you could check in. But you are absolutely right. If you like the .env file and you prefer that one, don't forget to put it in gitignore and do not accidentally check it in. Then everything is good. Absolutely. Good. Now, in order to access these user secrets, we need a NuGet package. And you can add this NuGet package using the NuGet Package Manager GUI. Please look up the NuGet package. You can find it by typing in configuration and user secrets. If you look for this NuGet package, you should see here the NuGet package Microsoft Extensions Configuration User Secrets, and you can install it. This step is not necessary when you use ASP.NET Core. When you use ASP.NET Core, this NuGet package is available automatically. But if you want to have user secrets in a console app, you need to manually add this NuGet package. Again, in the NuGet Package Manager, look for Configuration User Secrets, and that will give you the NuGet package Microsoft Extensions Configuration User Secrets. With that, we can go to Program CS, and in Program CS, we can start writing our first lines of code. We are going to create a configuration builder, var builder equals to new configuration builder dot add user configuration builder. I'm missing a using statement here. Okay, I don't get IntelliSense. Now I get IntelliSense. Now it's okay. Add user secrets of program. This line will give us access to configuration values which are stored in user secrets. We could also add a JSON file here, we could add environment variable support, we can add all the different sources for configuration values if we want. This is what the configuration builder is all about. In an ASP.NET Core application, you do not need this line because this is created automatically by ASP.NET Core. You know that already. But in a console app, it's definitely useful to have that. The last step is that we need is to build the configuration information, and we do that by calling .build. And with that, we can easily retrieve the OpenAI API key by saying config and then use the name of the variable that we set using the .NET user secret set command, and that was, in my case, OAI API key. And now we have the API key in a variable and can use it. Okay, I will zoom in so you can take a look, and I will give you a second to catch up and enter this code in your environment. Nice. Now we need a possibility to send HTTP requests to OpenAI. And we do that by using the HTTP client class in C#. We have used it in the past every now and then, but today we need it extensively. Please note again, in the near future, hopefully, the NuGet package for OpenAI will support the new APIs. That is currently not the case. This is the only reason why we are going to use HTTP client. If you do something like that in real world, maybe after your final exam, after your Matura, when you enter the business world, please check whether the NuGet package was updated. Prefer the existing APIs over directly calling the REST API. But now we have no other choice. We need to use the HTTP client. So let's create a new HTTP client. New HTTP client. And what we can do to make our lives a little bit easier, we can automatically set the so-called base address. Now, what will be the base address? New URI. We can look up the base address by taking a look at the REST API reference. If we take a look at the assistant APIs and scroll down a little bit, you will see that the base address is that one. Well, essentially we can take the whole thing together with the v1. That is our base address. So we can take this one. This is the use of the base address. It's very useful to be able to specify that during construction of the HTTP client. Please also note that you should not create a dedicated HTTP client if you have multiple requests after each other. The HTTP client class was designed to be reused. You do not need a separate instance for every call. It's essentially a bad thing. It's an anti-pattern to create an HTTP client per REST API call. You should reuse this thing. Otherwise, you can run out of resources, and that is very inconvenient. Good. Let's do another thing. If we take a look at the documentation, you will see that the system requires us to set, as you can see, the authorization and a header which is called OpenAI beta. Assistance equals v1. That's essentially the opt-in to the API, to the new beta API. So let's set these two headers. And we can do that by saying HTTP client.default request headers authorization, and then in this case GitHub Copilot is automatically suggesting a meaningful thing here. Authentication header value bearer with the OpenAI API key that we have retrieved from our user secrets. This is the header, and this is what the bearer token is all about. Good? Very good. Next one, let's set the HTTP client default request header, and let's add a new header, and then I can copy this one out. It says OpenAI beta, this one, OpenAI beta, and yeah, you see, this is a typical limitation of GitHub Copilot. It cannot provide a meaningful request here because the cutoff date of GitHub Copilot is somewhere in 2021. This API didn't exist in 2021, so this thing cannot suggest something meaningful. So if we use very new features, GitHub Copilot has very limited support. Maybe you have heard the GitHub Copilot AI assistant will be upgraded at the end of this month to hopefully ChatGPT 4. Then the system will be a little bit smarter. But still, these APIs are too new, so we don't get very good support with GitHub Copilot. We have to consult the documentation here. Let's put it somewhere here. Not the version, I'm sorry. I mistyped this. Of course it should say headers. And last but not least, let's be good citizens and add the the accept header so that we tell OpenAI that we can handle JSON responses by saying HTTP client dot default request headers accept, and probably, yeah, exactly, GitHub Copilot will fill out the rest. We tell OpenAI, hey, with every request we accept JSON as a response. This is a very useful strategy, configuring the base address and configuring default headers, because now it is very simple to send multiple requests to OpenAI. We do not have to specify authentication over and over again. This is done automatically. What I will do to structure my script a little bit is I will add some regions here. Setting up HTTP client. And here I will say end region in order to be able to fold that together. Okay? You can do that if you want, but obviously this is not a must. Okay, so now we can start interacting with the OpenAI API. We need a pretty long list of DTOs, and I did that work for you. So I sat down yesterday in the evening and wrote a lot of DTOs. They are not complete, so it is not the goal of this sample to support each and every API that is available. It's just enough that we can solve today's lecture. I just sent you a link via Discord to a GitHub repository where I have checked in the DTOs. It looks like that. Here you see region DTOs for OpenAI. Please take this entire region. It starts here at line 218 and it goes down until 342. Please copy all these lines into your application, put it at the end of your application. It's a pretty long list. You will probably have to add some using statements, especially JSON serialization. You can fold it together and forget about it. If you would prefer to put them in a dedicated file, in a separate file, feel free to do so. Yeah, you can absolutely do that. And again, I would like to emphasize, the goal of this sample is not to support all features of the OpenAI API. Don't get the wrong impression. It's not my job to do that. This will be done by Microsoft and OpenAI. Hopefully in the near future, we don't have to write this code by hand. In dynamic languages like Python or JavaScript, you do not need these DTOs, but we are working here with C#, so we need definitions for these responses, and therefore we need the DTOs. I told you, I have to admit that I wasn't able to complete everything, so I know there is a known bug inside there when it comes to function calling, and probably at the end of this lesson we will have to do some debugging together, because I tried to fix it today in the morning. I fixed a lot, but this last step I hadn't enough time. I apologize for that, but that's a good exercise. Then we can do some debugging together, right? Good. Could you copy these DTOs? I think it would be boring typing these DTOs by hand, so I thought, why not saving you the trouble here? Good. Now we have the DTOs, we have set up the OpenAI client. Now we can start managing the assistant. Let's start by creating the assistant, okay? And I would like to do the following. I would like to set up an assistant and then check whether the assistant already exists. If it already exists, we leave it as it is. And if it doesn't exist or is out of date, we will update it or create a new one. We call this principle idempotency. Have I mentioned this word in the past? Have you ever heard from idempotency before? You say yes. What is idempotency? Can you try to describe it?
Basically, if it's different.
Exactly, that's the point. You can, without any problem, repeat the job. You can run it 2 times, 3 times, 4 times, and it will not lead to bad results. So in our case, by checking whether it already exists and only trying to create it when it doesn't exist, we make our program idempotent. That's a very important concept when you design systems. Idempotency makes your software more robust. Because if something bad happens, you can simply retry without having to fear that something breaks. Got it? That's also a very important concept when it comes to databases. For instance, if you have to create a user and then create an order for the user, you should make such a process idempotent. Because maybe your first run fails when creating the user, then you rerun it and no, sorry, your program, the first run, fails after creating the user, so you didn't create the order. You want to rerun this, but then your program doesn't work anymore because it tries to recreate the user which already exists. That would be the opposite of idempotency. Good, so let's do that. Let's first, Region, get a list of all assistants. And you will see there are some interesting aspects of this API that we should definitely take a close look at. It looks like that, var assistants equals to await HTTP client, and then we can use a get from JSON async, and there we specify the schema of the output, and that would be OAI result of assistant, and then we go to the assistants. This is how it looks like. Now let me tell you a little bit about the API design that OpenAI has chosen for this use case. Let's take a look at the list of assistants. You see that this is the correct URL, so we are using the correct URL, but now comes something which is very interesting. As you can see, OpenAI supports a list of query parameters. And the interesting thing is the paging logic here. Of course, you can have more than 20 assistants. You can have hundreds of assistants, absolutely no problem. But OpenAI doesn't want to return all of your thousands of assistants in every single HTTP call. So therefore, you can limit the number of requests, the number of responses between 1 and 100. The default is 20, so you will get the first 20 assistants. You can specify an order if you want, and then you can specify for paging if you would like to have the second page, the third page, the fourth page, and that is specified by specifying an after object. So you get the first 20 results, then you remember the last ID, and then you can say, give me the next IDs which follow after this ID, which I already got. Got it? So let's draw that to make it very clear how this works. If this is the list of all your assistants, the first call will return by default the first 20. You remember the assistant ID at the end, and with the next call you can say, give me the next 20 after the ID that I got before. That's a very typical approach for designing REST APIs. Paging is the concept here. Well, in our case, we luckily only have a few assistants. I think we are less than 20 people here in the room. I think we are. Yeah, I think we are today, less than 20 people, so we don't have any problems with our paging here. So let's forget about the paging to keep things simple. But you see, in reality, it is a little bit more complicated to work with these APIs. Luckily, you have these NuGet packages that I was talking about before, and they will solve this problem for you. Now we check whether we have an existing assistant. Existing assistant. And then let's see what GitHub Copilot suggests. Yes, I think that looks good. And now here, please, everybody choose his or her own assistant name. I will say this is Raina's assistant. Please use a name that is unique for you. Use your first name and last name, just your last name, your student ID, whatever, something which is unique. Don't just call it assistant because many of you will call it assistant. And don't use rude names, please. Otherwise, we get locked and we don't want to do that. So just friendly names, whatever you want to use. So let's get rid of this one. Now, what I essentially do is I'm saying, give me all the list of assistants, and then I'm checking whether there is an assistant which belongs to me, which has a certain name. As you can see, the OpenAI API does not support querying, filtering for the name using the original REST API. They've chosen to build a very simple API which just supports paging. The APIs that we build together are more elaborate. They are more capable of what OpenAI currently supports. But this is a beta version. It's very likely that they will come up with more advanced versions in the upcoming future. Very good. That should give us the existing assistant if there is one. Now, if you run this program for the first time, you will obviously not get your existing assistant, but still we can try whether we get something back. So what I'm going to do is I'm going to set a breakpoint here and press F5 to debug my application. I select the C# debugger. That should start my app. And in a few seconds, my app should be up and running. The breakpoint should be hit. Come on. Here we are at the breakpoint. And we see the response status code does not indicate success, 404 not found. So what did I do wrong? That is not a good idea. Let's check. I think the list assistants, I think I screwed up here. Let's get rid of this V1 here and put this V1 here. We'll see. Try it again. Come on, debugger. Let's get started. See what we have here. Much better. Sorry, I did something wrong. I put the V1 here in the base address, but that is not supported. So I took the V1 and put it here. And now we can take a look at the assistants. And if we take a look at data, you will see that we currently have 2 assistants. And these are exactly those 2 assistants that you have seen in the playground before. So this is the goal. Please verify in all your environments that you can successfully query the list of assistants. Your assistant will not be here yet. We have to set up the assistant on our own, but you should be able to successfully call the API. Very good. Everybody can access the API. We got a list of assistants. Now we can set up our own assistant. I will create another region and I will say define data for assistant. Now we have to do a little bit of prompt design. Var assistant equals to new assistant. I created that one for you. And first, we have to specify the assistant name. In my case, that will be Raina's assistant. Obviously, in real world, we will not use a magic string here, but we will use some configuration settings, or maybe we ask the user for the name, but hey, this is just playing around with this stuff, so it should be okay. Next will be a description of the assistant. Please think of what your assistant should do. In my case, for the first sample that we are going to do, we will not start immediately with a fundraising example. I will say assistant for suggesting what to do in Vienna. Possibility. Next one is the modal. Okay? Which modal do we want to use? Now, it's kind of funny. GitHub Copilot suggests the Da Vinci modal. Why does it suggest an artist here? Well, that's the old version of the modal name of OpenAI. When GitHub Copilot was trained in 2021, DaVinci was the state-of-the-art model, but nowadays it's very much outdated. So we are not going to use the model here. Let's check what the model is that we can create here or can use here. OpenAI provides a model overview page. You can get it from the documentation here. And if we take a look, we see all the different models which are currently supported. In the deprecated part, you will see old models, and somewhere in there we should see DaVinci. Here you see DaVinci. That's an old one. Don't use this one. It's outdated. The interesting ones that we are going to use as of today, that's December 2023, we are going to use GPT-4 Turbo and GPT-3.5 Turbo. To be more specific, if we take a look at the detailed versions, we are going to use GPT-4 version 11.06 preview, and we are going to use GPT-3.5 also version 11.06. As developers, you have to be more specific than as end users. As end users, many end users just talk about GPT-4 or GPT-3.5. But as developers, we know it better. We know that there are multiple different versions that you can use. And here you see there is, for instance, an older version of GPT-4, which is 0613, and so on and so on. You can read the documentation on your own. They have very different properties and also very different pricing. The context window of GPT-4 is pretty impressive, with 128,000 tokens for a context window. And the response, I think, is limited to 4,000 tokens, something like this. But still, it is pretty impressive what GPT-4 Turbo can do. Okay, so in our case, in order to save a little bit of money, I'm going to start with the GPT-3.5 Turbo 11.06 model. We can switch to GPT-4 later. So this is what we are going to specify here. So now you know, if you program with OpenAI, where to look for the current model versions and for the exact specifications of the model. They are documented in OpenAI's API documentation. Good. Next, we need to specify the prompt, and we can use the multi-line constants here. This assistant helps you to find out what to do in Vienna. Yeah, that's possible. Let's make it a little bit more interesting. You are a helpful assistant suggesting what to do in Vienna. Answer always in German. End every sentence with oder. You can leave that out. We'll see whether GPT-3.5 understands the Austrian language. Okay. Last but not least, we can specify the tools that we have. We will need the tools here when we specify that we have some internal function calls. This is the function calling part. But for our very simple sample, we do not need tools at the very beginning. So that would be a typical setup of an assistant in OpenAI. Give it a name, select the version of the model, and then do prompt design. And don't underestimate how much work it is to come up with a good system prompt. It's especially true for GPT-3.5. In GPT-3.5, you have to experiment quite a while until you come up with a prompt which works properly. I highly recommend that you do not do the prompt design here in this API stuff. Go to the playground and try it here. So I can, for you, because you probably don't have access to this playground currently, only a few of you will have that. I will simply try this prompt and we will see whether this prompt makes sense. So I copy these files down here, I will save it, I take the GPT-3.5, clear everything. I am in Vienna overnight. What should I do today in the evening? First, we will see whether GPT-3.5 follows our guidance that it has to answer in German. Ah, geh zum Prater und mach eine Fahrt im Riesenrad, oder. Danach kannst du einen Spaziergang durch den beleuchteten Stadtpark machen, oder. Oder besuche eine Vorstellung in der berühmten Staatsoper, oder. Viel Spaß in Wien, oder. Well, maybe I have overdone it with the oder, but I think you get the idea, right? It understood the prompt, and now you understand what this instruction is all about. We can tell ChatGPT how it should behave, what it should do. And if you take a look at the logs, you will see that this is what we have to do. First, we have to post it. We have to, what is that? Oh, sorry, I have to scroll up. We have to create the thread. We have to add the message. We have to run the thread. Then we have to wait until the run status is completed. Then we have to get the messages, and then we will get, hopefully, an answer. Okay? Good. So again, do prompt design using the tools that OpenAI and or Azure provide. Awesome. So now we can write the code which is required to update or create the assistant. Region, update or create the assistant. And region. How can we do that? Well, let's simply say if existing assistant is null, okay? If the existent assistant is null, then we know that the assistant does not exist yet. Okay, that is good. So we need to create the assistant. So we need to create it. And that is pretty simple. Well, maybe let's print the status message. Let's say creating assistant. That might be useful when we run our program and debug it. And let's see what GitHub Copilot suggests. It suggests something which makes sense. Okay, var result equals to, well, I'm going to call it response, but in general, that is okay. Yeah, that is pretty okay, I think. Good. So that would create our assistant. And we can immediately try that one. So let's run the app, .NET run, and let's see what's going to happen. Very likely, we will end up having a lot of assistants. Please do not run your application 100 times, because then we will end up with 100 assistants, and that would be kind of boring. Run it only once, and that should give us, in the playground, a bunch of assistants. Let's see whether it worked. Okay, I already have Raina's assistant. Let's see whether you run your apps too. At least some of you should run it. Ah, I see, Bilal's assistant. And we have many other assistants probably in a few seconds. So, oops, sorry. It worked. We can interact with the OpenAI API and we can create assistants. You have a question, please. Nice, so we have solved all our tiny little problems and we can complete our application. What should we do if the assistant already exists? Let's say else. Well, if the assistant already exists, we have to check whether something changed. So we can say if assistant, that's the one that we have defined in our application, .name not equal to existing assistant.name. Yeah? And then we can hopefully rely on GitHub Copilot to generate the rest. Description not equal description, modal not equal modal, instructions not equal instructions. And with that, I think we should be pretty okay. Okay? If something has changed, we need to update the assistant. Okay? So console write line, updating assistant. And here we will see something pretty interesting. If I would ask you in an exam, which HTTP verb are you going to use for updating a record? Post, patch, put, delete, or get? What would be your answer? Put or patch? Exactly. And guess what OpenAI did? They were not in my class. They are using post here. My guess why they are using post, it makes sense that they are using post here, is that patch and put requests are sometimes, in some very restricted environments, they are simply not allowed. I've seen customer networks where they only allow get and post. They don't allow any other HTTP verb. And I guess this might be the reason why they are using post here. Strictly speaking, if you follow the HTTP standard by the book, if you take a look at REST APIs, they typically use put and patch for these things. But OpenAI made a different decision here. We can think it's good or not good. It is like it is. We have to follow their API design. We have to use a post here. Nevertheless, here in this school, we follow the principle of put and patch. So when it comes to your final exam, to your Matura, and you are asked to design an API, please use put or patch. But you have seen, in practice, sometimes people use different verbs that you might expect. Good. So now that we know that we can update using post, it shouldn't be a big problem. We can essentially use exactly what we used before here, but this time we have to specify the existent API in the past. So let's use a $sign here, and here we are going to use the existing assistant ID. Because if you take a look at the documentation, you will see that the assistant ID that already exists is part of the URL, exactly like we have done it in the past. Good? Nice. And what happens if everything is the same? Well, then we don't need to do anything, so we will simply write assistant is up to date, so that we know that we didn't have to do anything. Now, of course, we need to analyze whether the update or insert operation was successful. And we can do that by taking this response variable and move it outside of the if statement. So we can say this is an HTTP response message. Let's call it response. Let's set it to null at the beginning, and let's remove that one here, and let's remove that one here. So if we make an insert or we make an update, then response will have a value. If the assistant is already up to date, everything is fine, we don't need to do anything. Good. So after this if statement, we can say if response not equals null, we can check some things. Well, the first thing that we can do is we can say response !ensure success status code. This small little helper function will help us to very easily verify whether the result was a 200 response code. 201 created, 200 okay, something like this. If the response code was a 400 response code, something like not found or bad request, or a 500 response code, internal server error, this will throw an exception. Okay? So if you just want to find out, hey, everything should be okay, make sure that everything was okay, you can simply call ensure success status code. Good? Now let's read the assistant. Existing assistant equals to await response content read from JSON async. Yep, that is what we can do. The only thing is here, now we can use a, we have the check here, so we don't need these things here. Yep, should be good like that. And with that, we should be okay. Maybe at the end, we can write the assistant ID on the screen to make sure that we see it. If you managed to write this code, I will show it to you in a second, let me quickly try it. You can run your app, and in my case, it should now say not creating assistant, but assistant is already up to date, and I get me my assistant ID. You can verify whether it works by changing a little bit. For instance, in my case, I will say end last sentence of your response with order. Because I overdid it a little bit with the order here. And if I run that, the system should tell me that the assistant has to be updated. It does it correctly, exactly like we want to use it. I will let the code here on the screen so you can verify that you have the same code in your code base. Nobody seems to have problems. That is very good. Oh, we have 2 problems. Let's fix these problems and then do our break. And after the break, we are going to start sending messages, creating a thread and then sending messages to the thread. Okay? So let's go into the break. But before we go into the break, let's fix the small little problems that you have. So welcome back after the break. Let's continue just to refresh your memories. The last thing that we did before the break is we created the assistant or updated the assistant, and we talked a little bit about the API design of the OpenAI API. And next we are going to create threads. These are the threads that are persisted. So if you have multiple users on your website who simultaneously chat with your bot, then you will have multiple threads going on at the same time. You can also save a thread, and when a user comes back, maybe an hour or a day later, logs in, you can continue the thread. In the past, I told you that before, in the past you needed to store the messages yourself, and now we have the Threads API. Yes, question?
How does this work with the chat? Not the chat, right? Storing the messages because they use their own API.
Yes, they use their own API.
How?
Which chat do you mean?
The ChatGPT we use to.
Okay, you're talking about the regular ChatGPT, so you are talking about this thingy here, right?
Yeah.
Exactly. They have their own database and they are using their own APIs behind the scenes. However, the new portal that you see here, as far as I know, is already based on the new API, but on an unpublished version of the new API, because it supports streaming. But I don't know the technical details. I have never taken a close look behind the scenes. I've never reversed engineered it, but this is what I understood from their presentation. Okay? But yes, they use their own persistence API. But if you want to build your own API your own UI in front of it, then you have to do this storing yourself. Okay? A lot of companies are nowadays building their own UI on top of OpenAI because they want their own user experience or other things. Good. Nice, nice. So let's create a thread. Region, create thread. And region. This is what we are going to do. And let's take a look at the API of the threads. Here you see, creating a thread is very, very simple. You will essentially send a post request to OpenAI VI threads. Here you see the create thread, here you see it, with an empty body. You can, if you want, immediately start with a list of messages to begin with. So if your API, your user interface, would like to, for instance, automatically add some greeting message, then you could do that. When you create the thread, you can immediately support some messages, but we will not do that. Additionally, what you can do is you can attach metadata. See? You can attach metadata to a thread, so you can later on identify the thread or maybe read this metadata to understand what is the user. You can use the username, the first name, the last name, some metadata which might be useful for this thread. So let's create the thread. As I told you, we can send an empty message to create the thread. So var new thread response equals to await HTTP client post async. Now post async requires us to specify, as you can see it here, a request URI and an HTTP content. So the URI is pretty simple. If we take a look at the URI is simply OpenAI v1/threads. So we can say v1/threads. And the second thing is we need to specify content. Well, the thing that we can do is we can specify a string content here. Say this is an empty string content. I want to encode encoding UTF-8. And we want to send application/JSON. Now this call here sends an empty body using the post request to the endpoint v1/threads. Okay, let's ensure that it was successful by calling the ensure success status code, and then we can deserialize the response var new thread by calling the read from JSON async, and I created the DTO for you. That's the created thread result. The created thread result essentially only contains the ID. We are primarily interested in the identifier, the primary key of the thread, because this is the thing that we are going to use later on. Therefore, I will make my life a little bit easier by defining a thread ID variable and extracting the ID directly here. So I have it in a variable. Okay? This does nothing magic. Currently, no artificial intelligence is involved here. It's just creating a record in a database behind the scenes. Nothing more, but also nothing less. To make sure that we don't leave anything laying around, let's create immediately another region just to clean up, delete the thread. That is something that's kind of, let's say, garbage collection. We don't want to overwhelm the system with an endless number of threads just to try it. So what I'm going to do is I'm going to say await HTTP client.delete async, this one. And there we are going to use the threads with the thread ID, and that's essentially it. That's just cleaning up. Maybe let's write a status message deleting the thread. So we create the thread, then we will interact with the thread, and at the end we simply clean up by deleting the thread again. Strictly speaking, this wouldn't be absolutely necessary. We could also let the thread lay around. I have no idea how long OpenAI will keep the threads. I didn't look it up in the documentation. I don't know if there is an end date to it. However, I want to be a good citizen, so let's delete what we do not need anymore. If you got this code, give it a try, run it. It should say assistant is up to date. We should see an assistant ID. It should say create the thread and delete the thread again. Oh, I forgot the status message here. Let's say creating thread so that we see what we do. My program works. I didn't get any mistakes. And I will also add a status message here just so that we know the thread ID. It's kind of interesting to see which IDs we have. I want to make it a little bit more beautiful, so I will add a tab character when displaying the IDs. Something like this. Let me try it again. Hopefully it works. Yep, this looks good. Assistant is up to date. I get the assistant ID, creating thread. I get the thread ID, deleting the thread. It works for me. Please try to follow along and let me know if you have any problems. No problems, that is good. So, between creating the thread and deleting the thread, we are going, as next step, add a message. End region. Good. Let's add a message. Status message, no problem. Let's take a look at the API and analyze what how the API works. Let's take a look at the create messages. As you can see, OpenAI is really using the RESTful Web API principle in designing the path. just as we have learned ourselves, they are using the threads here as the top level criteria. Then you have to specify the thread ID, and then they use messages, which you can use to create messages and also query messages. So the thread ID is a mandatory parameter. We have to specify that. And then in the request body, we have to tell the system what is the role. Currently only user is supported, so we can only create user responses. Okay? We can also only say the user has entered this and that. Then we have to enter the content of the message. That's just a string. And what we also could do, if we use code interpreter or retrieval, we could upload a file. Now, this functionality is important when you want to rebuild ChatGPT's attachment functionality, you see? If you use ChatGPT, you can type in a message here. We know that. This is what we are going to do. But you can also upload a file together with the text that you just entered. So if I click on this paperclip here, I will get an open dialog and I can select any file that I would like to upload. If you want to rebuild this functionality, you have to use the, you have to use the file IDs here. There is a dedicated API for files. I think it is the message file object, you see? There is a dedicated file API with which you can upload files. I think it is also here. Create assistant files. We talked about this with the assistants, and now we have the file upload with the messages. But we don't care for our example. For our example, we do not need to update files, upload files. That would be a little bit too much for the amount of time that we have today. So all that we need to specify is the role, which is user, and the content. Essentially, the role is fixed. It's always user, so the only thing that we have to specify is the content. Good. Let's do exactly that. So we say var new message response equals to await HTTP client and so on. Let's see. v1 threads, thread ID messages. That looks good. I will put that in the next line. And here we specify the new create thread message. And here you can now specify any message input that you would like to specify. In my case, I am doing an assistant about sightseeing in Vienna. So I will tell the system, hi, I will stay overnight in Vienna. What could I do for the next... where can I find the best parties? Why not? By the way, I love music very much. We'll see. We'll see what the system will tell us. You get the idea, right? That's the analogy to entering data in the user interface, but this time we will do it using the new beta API. Once we send that one, we can of course make sure that the request was successful by simply calling ensure success status code again. It doesn't make a lot of sense to run this now because it will not do anything. Again, this is not involving any kind of OpenAI large language model. This is just adding a record to an internal database that we do not see. In order to activate OpenAI ChatGPT, we need to create a run and then wait until this run reaches the completed state. Okay, so it doesn't make sense to run this program now. If it is syntactically correct, we can continue. Good. So let's add a new region and let's call it, I don't know, create run. Let me point out something which is very important here. In this example, we simply write the whole process in a single file because we are just experimenting. In real life, you would obviously separate that into multiple classes and files, and you would have a lot more error handling and things like that. But I think you got the point, okay? We only have 4 hours, so we want to keep it, we want to focus on what's really interesting today. So let's specify a status message and try to take a look at the run statement, at the run API. So let's take a look at the runs. Here are the runs, and here we can create the run. Now the parameters for the run are pretty simple. They are first the thread ID. This is the list of messages that we want to the ChatGPT system to process. We need to specify which ID, which assistant should process the messages. This is kind of interesting. Listen closely, because this is an important concept here of the API. We created the assistant at the very beginning of the process, but we didn't assign the assistant to the thread. The assistant ID is specified when starting the run. So what we can do is we can switch the assistant depending on what we want as a result. So we can have a chat history, and we can start a run with modal 3.5, and we can use exactly the same thread to use a second run with modal 4 turbo, and then, for instance, compare the results. So assigning the assistant is not a property of the thread, it's a property of the run. Got it? Threads are not linked to assistants. An assistant is independent of the thread. Yes, question?
If you open like the one chat you have,
Yeah.
you ask 2 different questions, you can give 2 different assistants.
Yes?
So the answer is fitted to the question.
Yes?
Basically.
Yes, of course. But both different assistants follow their instruction. You can give them different instructions. So if you need for your application to distinguish, in this situation I want to have the intelligence of GPT-4 and I'm willing to pay more, and in this situation I want the intelligence of 3.5 and I want to pay less, you can do that. Okay. Please keep in mind, all these APIs are subject to change. They are beta. So it is possible that OpenAI decides to change these things. But currently it is like it is. You can also specify, or let's say override, the modal. This is also interesting. You can say, I want to use an existing assistant, but please do not use the modal which I specified at the assistant level, but I want to override the modal. So if you want to do experiments where you use the same assistant, but one time with this modal and one time with this modal, you can absolutely do that. The important thing here is that this is optional. If you do not want to override the modal, simply do not specify a modal, and then the system will take the modal out of the assistant. Okay, got it? Good. The same is true for instructions, the same is true for tools. You can override the settings of the assistant per run. Not per message, per run. Good? Very nice. I simplified the creation, the API very much, because in our situation we simply assume that we do not want to override any features of the assistant. So I simplified the DTOs. But by looking at this data model of the API, you now understand why the NuGet package for OpenAI has not been finished yet. It will not be a trivial .NET API. There has to be done quite a lot of thinking how to structure this API. The OpenAI API got way more powerful and complicated in this new version. Before, it was trivial. I would even say trivial. Now it's a little bit more options and you have to understand more. Okay, let's stop talking, let's start running. Okay, so var new run response equals to await HTTP post as JSON threads runs. That looks good. Create run assist. Yeah, GitHub Copilot made it perfect. Yeah, this is exactly what I want. Let's structure it in 3 different lines so you can see the parameters better. So GitHub Copilot was perfectly capable of generating this call for us. Not because it understands the API, but the OpenAI API aligns to typical patterns that GitHub Copilot knows from other REST APIs. So it was pretty simple to generate the code for Copilot. Another thing that was important is that I used good naming for my DTOs. For instance, here I said there is a DTO which is called create run. By giving it a good name, create and run, GitHub Copilot was capable of automatically suggesting that for creating a run, I will use the DTO create run. You see, it's very important to use good names, good record names, good class names, good method names if you want to productively use AI assistance in coding. Good? Clear? Nice. Now we created the run. Of course, we need to ensure that everything was okay. So let's just call ensure success status code to know early that everything is fine. And last but not least, we need to deserialize the JSON to get the run ID. But that shouldn't be a problem. We simply deserialize the run from the JSON and that's it. Now in new run.id, let's store that in a variable. Run ID is new run.id. We have the ID of the run, and I will print this one out so that we have it on the screen. This still isn't very interesting to run, because now the run is started, but we never see a result. So now we have to implement a loop where we regularly check whether the run has already been completed. Got it? This is exactly where we are lacking the functionality that I was talking before, streaming. If we would have streaming, we wouldn't need to poll. We wouldn't need to ask again and again, are you done? Are you done? Are you done? Are you done? Are you finally done? We would not need that. But currently, we need to do that. Well, that is not very complicated. Let's create a new region and let's wait for the result. Region. Wait for completed and region. Right? Wait for status completed. Yeah, GitHub Copilot will generate waiting for status completed automatically. That is good. Then let's do a while loop. While new run.status is not completed. Okay, good, let's do that. Let's again write the console write line. Come on, console write line. I don't know, checking status or something like this. Checking status. And then we need to check the status, and we do that by retrieving the run. So we have to send a GET request with the run ID, and from the result we can extract the status, and we have to wait until the status is completed. In the guide here, they describe the process in way more details. If we scroll down, you will see that here, where is it? Run the assistant, blah, blah, blah. Here it is. Check the run status. This is what we do. By default, a run goes into queued state. You can periodically, that's the polling, retrieve the run to check its status to see if it has moved to completed. And that's exactly what we want. Got it? If we take a look at the playground, we will see exactly the same. Where are the logs? The logs were gone. So let's try it again. So that you see it here. Run. Thread, message, run the thread. Status, you see? Do you see how the get status was called multiple times? Here we see that I have to change the size a little bit, but I think you get the idea. These are the whole checks here. Now let's take a look at the run status. The first status here was in progress. See that one? And if we take a look, we do not have any responses here. Now if we take a look at the last one, we have completed, and once we have completed, I showed you that before, we can get the run and retrieve the messages. So we are just waiting until this thing has been completed. If we take a look at the run steps before, this is the status, this is the status here. No, the run steps, I'm clicking on the status here. Where is the status before? Here is the status before. We have the in progress. I showed you that already. So nothing interesting here. Good. By the way, are you familiar with these numbers here, started at? Does everybody understand what this number is? It's a time. It's a timestamp. Do you recognize the format? Yeah. Yeah, but it has a name. Have you ever heard of the Unix timestamp? This is a very famous format. So, for instance, if I enter the created at time here and I convert it, I will get back December the 14th at 9:30. That's exactly when we tried the exercise. Of course, that's GMT 0, so you have to keep in mind that we are not at UTC. Yeah, so you have to calculate the time difference here. So this format is called Unix timestamp. Okay. Of course, .NET is capable of turning Unix timestamps into regular date times. Use Google or your favorite AI assistant to learn more. Good. Yep, I like that. So now we check the status. First, before we check the status, maybe we should wait for a second. So let's say a wait task delay. Do you agree? If we wait 1 second and after 1 second we recheck, I think that would make sense, right? Let's try this one, okay? Then we will retrieve the run status. So we say run response, get async, blah, 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 with the run ID. I think this looks good. We can even make it a little bit easier. We can say get as JSON, get from JSON async, and specify directly the run here, because this is what we are asking for. Run. Okay, this looks good. And maybe print, console write line, print the status on the screen so we can see what the current status is. And the system will automatically exit the loop once the status has reached completed. And now it makes sense to run the program. Let's try it. I will try it on my side, and you can try it on your side too. It will first update the assistant, create the thread, creating the run. You see? Checking status, in progress, completed, done. But why doesn't it stop? Because I made a mistake. I'm very sorry. This should of course be new run equals 2. New run. But you already saw that we are reaching status completed. So let's run it again to see whether it now ends correctly. Adding message, creating run, status in progress, checking status, deleting thread, everything is fine. Please make sure that the program works. We don't print the result on the screen yet, but we essentially see that the run really completes. Okay, before we move on, let me make a note regarding security. Please keep in mind that the OpenAI API does not distinguish between users. If you build a website, for instance, with an assistant, and the end users will type in personal information regarding the questions, then everybody who has access to the OpenAI key can retrieve the messages that the users have typed in. Imagine, don't do that, okay, because that is beta, but imagine you are creating a bot where people can ask for assistance if they are sick. That means that people will probably enter their health status. That is critical personal identifiable information. Personenbezogene Daten, kritische personenbezogene Daten. You are essentially storing health-related data in a database at OpenAI. And I can query all the messages of all my users by using a single AI key, a single API key. You get the idea? That's very relevant for data security. That's very relevant for the GDPR, for the Datenschutzgrundverordnung. So keep that in mind. You need to add an extra layer of security to make sure on an application level that one user cannot somehow access the messages of another user. And if you screw up, if you accidentally print the message history of user A, although user B signed on, you have a critical security vulnerability. This is why most of the public APIs and most of the public websites that use AI always have a disclaimer at the bottom where they say do not share personal information like your name or social insurance number or something like this to this AI assistant, because this data will be stored. Previously, in the old API, this was not the case. The old API, you had to send the entire message history with every API call. So OpenAI did not store this data. But now OpenAPI acts as a database. And as you might know, the GDPR has very strict regulations when it comes to the location of storing personal identifiable information, PII. This is an important English term. You should definitely remember it. Again, PII, Personal Identifiable Information, personenbezogene Daten. Okay? So keep that in mind. This is important. That is why many of my customers are not using OpenAI. They are using Microsoft Azure, because in Azure you can deploy the OpenAI models, but you can choose the data center you would like to run it in. So you can define that your OpenAI model should run in Switzerland, for instance. And that's a better situation when it comes to GDPR. Got it? So keep that in mind. That is something that you as a developer have to consider. Nice. Once we reached the completed state, we can now list the messages and print the messages on the screen. Let's do that, okay? Once we got the status to complete it, let's create a new region. Region. Print the message result. End region. So print a status message. Let's call it listing messages of the thread. Something like this. I think that is okay. And then we can get the messages. Let's take a look at the message API so that you understand what we are doing. We are currently here, messages, list messages. This is the API that we are now using. Retrieve a list of messages for a given thread. Good. So var messages equals to, yep, that looks pretty good, what GitHub Copilot suggests here. Okay, let's iterate over the messages. For each var m in messages. What? Sorry, messages.data. That's maybe an interesting aspect here. Take a look. The OpenAI API always puts lists. If you get a list of arrays back, always puts it into a dedicated property which is called data. So the list is not returned as a top-level element, but it is inside the property data. That's a design decision that OpenAI made. So we need to access the data here, otherwise we don't get the list of messages. Inside the messages, we can have multiple pieces of content. So we need another loop here for each var c in message content. Messages, m dot content. This is what I want. Exactly. And then we can write it. So let's say 2 tabs, and maybe specify here the role, so that we see whether it was a message from the user or a message from the assistant, and then print the status text. And with that, it should work. So let's check what the API generates. Run ID, in progress, completed, awesome. The assistant in my case said, hey, in Vienna gibt es viele tolle Clubs und Bars, in denen du gut feiern kannst. Besonders im Bezirk Leopoldstadt und im Bermuda-Dreieck findest du viele angesagte Locations. Wenn du Musik liebst, solltest du unbedingt das Otterkringer Brauereigelände besuchen. Dort finden regelmäßig fette Open-Air-Partys statt. Viel Spaß beim Feiern, Alter. I like that response. I like that response. And here you see that the message history included the original message that we typed in, and it includes the response of the assistant. I will give you a second to try that on your own, and of course you can experiment with some instructions and some questions. Feel free to do so. In real life, we would now create a loop on top of it so that the user can type something in, get a response from the assistant. Type something in, get another response of the assistant. But this does not add any value to the general exercise that we do here, because you know how a loop works, and it is just a repetition of what we did in the past few minutes, just calling the same APIs in a loop. So I'm not planning to do that together with you. If that is interesting for you, you can definitely try that at home. But unfortunately, you have to deploy your own ChatGPT environment. Either you are a ChatGPT Plus user, or you use, for instance, your Azure credits to deploy ChatGPT in your personal Azure space. As you know, as students, you can get $100 per school year Azure credits. And with this Azure credits, you can, of course, play around with OpenAI. Good. I would say we have 3 minutes left in this hour, but I don't want to start with a new topic. We have 1 hour left, and that is perfect. That was my goal. Because in this final hour, we want to add function calling. So after the break, we are going to enhance our code and add a function to our assistant, and then we will check how we can process a function call. Okay, this is what we are going to try. But let's postpone that after the break, because we just have 3 minutes left and it doesn't pay off to start now. So enjoy the break, 3 minutes more break, and after the break we are going to continue with function calling. Welcome back from the break. I think we should continue so that we see a little bit about function calling as promised. If we want to get started with function calling, we first need to specify which functions we allow. And here I would like to save you a little bit of typing. So what I did in the sample that I prepared for today is I have set up a sample assistance that you see in the link that I gave you in the first lesson on line 40. Please take a look at the link that you got in Discord, and it's line 40 until 73. Of course, you can customize the prompt to your needs if you want, but I will simply take this one and then we will take a closer look on this prompt. The assistant name was, I think, Rainer's assistant. And the modal, I was too fast in replacing that. Yeah, it was Rainer's assistant and it was GPT-3.5 Turbo, and the rest will be replaced. And then we move Rainer's assistant here and we move the GPT-3.5 Turbo here. And with that, it should be fine. Nearly? Oh, here. Now we are fine. Now let me show you what I did in this example here. I specified the prompt. You're a helpful assistant supporting people doing fundraising by visiting people in their community. So just to refresh your mind, and also for the people who are sick today and maybe watch the video later. Last week, what we did is we created this sample, this fundraiser sample, and we checked in this sample here in GitHub in this example here. This was this fundraising example. The idea was that fundraisers, like for instance the Freiwillige Feuerwehr, the fire brigade, walks from door to door and asks for donations. That was the idea. And in our case we said we want to have an AI that can extract the relevant data for storing a visit out of a textual information. So when the user says, I just visited Birkenweg 16 in Leonding, family Stropbeck, and they were at home, it should intelligently extract the street name, the town name, the house number, the family name, and the information whether the family was at home from this text. This is the use case scenario that we want to fulfill here. So the prompt supports such fundraisers. Fundraisers will tell you about which households they visited, town name, street name, house number, family name. Additionally, they will tell you whether they met someone or not. Fundraising happens in Austria, so town and street names are in German. Additionally, I told the system, try to identify the necessary data about the household and the flag whether someone was met or not. Ask the fundraiser questions until you have all the necessary data. Once you have the data, and now comes the important part, call the function store visit with the data as parameter. Then we have to specify the store visit function. You have to understand that this function is not a web API. It's just a logical description what our host, what our application can do. You have to provide the logic in order to execute this function. Now let's take a look at the API design for function calling, because that is particularly interesting how they did it. Let's take a look at the tools section. I already told you about the code interpreter tool. We will not use that today. I already told you about the retrieval tool. We are not going to use that today. This is where we are interested in. The function tool. I will provide a function. And what you see here is you see that we have to specify a type, which says function. And then we specify the function with a description, a name, and a set of parameters. The parameters must, and that is the interesting thing that I want you to remember here, the parameters have to be specified in JSON schema. You are already familiar with JSON schema. JSON schema is the object description that you know from Swagger. Do you have Swagger files a little bit in your mind? At the end of each Swagger file, the data structures are described. What types do you have? What properties do they have? Which type does the property have? And so on. That is JSON schema. And as you can see, OpenAI makes heavy use of JSON schema. They have built the entire API on top of JSON schema. So if you take a look at what we do here, we specify the JSON schema for the parameters. We have to specify what is the parameter name. We have to specify what is the parameter type. These are JavaScript types, JSON. So you have string and number and Boolean, things like that. and then you have to enter a description of the parameter name. Normally, you do not care about comments very much, but here it is super important because the description will be the basis for the understanding of the large language model. Got it? Okay. So town name, street name, house number, family name successfully visited, and then you have to also specify which parameters are required. Does that make sense to you? So we tell ChatGPT that there is a functionality store visit that it can call. Or to be more specific, that it can ask us to call on his behalf. On its behalf. Got it? Questions so far? Nope? Very nice. So in order to get something meaningful, we of course have to change the message here. I will say, I just visited the family Müller. No. In Linz, in Dinghofer Straße, I don't know, 42. They were at home. Now this would be a meaningful task for the AI. It needs to understand, it needs to understand that this is the family name. It needs to understand that this is the town name. It needs to understand that this is the street name. It needs to understand that this is the house number. And it needs to derive the value true for successful visit from the sentence they were at home. Got it? That's a non-trivial problem. Let's see how the AI works. You know what we are going to do? And that is a best practice. Do not try that in your API immediately. Go to the playground. Let's try the playground first to see whether this stuff happens. Because what we need to do here, we need to do some prompt design. However, setting up this function in the playground is not a trivial task. So I will do the following. I will simply here at the end set a breakpoint. Just watch, okay? You can try it in a second. I will run the code in the debugger so that it will update my assistant. Okay, it runs. And yep, continue running. Come on, continue running. Continue running. Okay. I have the wrong breakpoint here. Sorry. Okay. Updating assistant was correct. Now let's go back here into the playground, reload the playground, and select the assistant, Raina's assistant. Where do we have it? Here we have it. And in the assistant, you now see that we have a function. See? This is what we just created using our API. And if we take a closer look at the function, you will see exactly the function specification as we had it in our application. And this is JSON schema. This is a JSON schema description of the properties and the name of the functionality. Okay, so that sounds pretty nice. So let's copy the message here. And let's try that one. Let's clear it, hide the logs, enter this message, and see what's going to happen. System works, and hopefully will exactly that is what we want to have. Do you see? In this case, we now do not get an answer from the AI, but the AI tells us that it would like to store the visit. It correctly identified the town name Linz, the street name Dinghofer Straße, the house number 42, the family name Müller, and successfully visited is true. If we take a look at the logs, we will see that the run status here, the last run no, this is the wrong one. This is the last run status. The last run status is now not completed, but the last run status is requires action. So ChatGPT tells us, hey host, I cannot complete this run. I need action from you. I need you to call this method for me and tell me what the result of this method was. So in theory, we will probably not have enough time to do that. I can specify here success, true, something like this. That could be the response. I have no idea why ChatGPT tries to call the method twice. Whatever. Submit, and hopefully, come on, submit it. Okay, it crashed. Good. Cancel run, try it again. So let me try it again. Maybe I did something wrong. Good, press run. Ah, okay. Obviously I screwed up. Maybe I clicked the button twice or whatever. Now we can say success, true, submit. See, continuing the run, and now the assistant says the visit to the Müller family in Linz, Dinghoferstraße 42 was successfully recorded. Woohoo! That's exactly what we wanted. This is how function calling works. So instead of waiting until the run says completed, we have to check whether we need to do something for the AI. Then we have to perform the action, and then we have to submit the function response in order to get the response of the AI. Okay? However, now I want to demonstrate something which is important. I will now be a little bit more stupid as a user. I will just say, I just visited the Müllers. What would you expect the AI to do? Well, probably it should ask us, okay, where do they live? See? It hallucinates. 3.5 Turbo says, hey, I know the Müllers. They live in Hauptstraße 12 in Vienna, and we visited the visit was successful. That's rubbish. That's simply wrong. That's a clear case of hallucination. And this is where 3.5 is not very good. So we would need to spend quite a bit of time to fine-tune the instructions so that it does what it should do. However, if we cancel that run and clear everything and switch from GPT-3.5 Turbo to GPT-4, save this thing and enter again, I just visited the Müllers, run. Let's see what GPT-4 does. It takes longer. We know that GPT-4 is small. Ah, see? That is what we want. To record our visit properly, could you please provide me with the town name, street name, house number of the Müller's household? Also, were you able to meet someone during your visit? They live in Linz. Okay, we make the AI's life a little bit hard, so we only provide the name of the town. Thank you for that information. Street name, house number, and blah blah blah. But did you see what GPT-4 was capable of doing? It recognized that Linz is a town name because it is pre-trained. This is why it's called a GPT, a pre-trained model. It understands that Linz is a city. Well, maybe if you take the smallest town near Linz that nobody has ever heard of, that consists of 3 farmhouses and nothing more, maybe it has some hard time to recognize the city, but if this is a meaningful or a larger city, it will probably recognize it correctly. Now we can say it is in, let's say again, Dinghoferstraße 42. They were not at home, for instance. And if you specify that, it hopefully will trigger the function call. Yep. It analyzed the town name, the street name, the house number. It had problems with the umlaut, you see? That's an interesting one. it couldn't correctly identify the umlaut U for the Müller. Okay, it is like it is, but it at least understood that Müllers is the plural of the family name. It would be interesting if we would have specified the instructions in German, whether it would have been better in extracting the umlaut here. But at the end of the day, it is like it is. Maybe it's also just a display problem. We can check that one. Let's see, post the thread, run. That should now here, the run steps, data, blah, 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 step details, tool calls, function, arguments. No, it's not just a display glitch. It is really inside of the parameters. So it seems that the AI function calling has in this situation a problem with umlaut. Okay. I'm just the messenger, don't shoot me. Good. So you understood how it worked, right? Good. Let's go back to our application and stop the debugging here. Let's add the functionality. Let's see how much time we have. Yes, let's add the functionality to here in the while loop. I encourage you to now join me again, because the loop needs to be changed. It's not just completed. We have to say and not requires action. Completed means we are done. We are done with the execution of the run. Requires action means that we need to do something on behalf of our AI agent. When we print the message result here, we cannot simply print the message result. We have to make sure that we need that it's a good idea to print the message result. Because here we are listing the messages, but this does not make sense if we are in the required status case. So what we need to do here is we need to here use a switch statement, for instance, and switch over the new run.status. If the status is case completed, we can, if we want, print the messages on the screen. So I will use it like that, do a break, and here. The other case would be requires action. And close the curly braces. Here we need to add additional code. Do you understand the difference? Completed means here you have the response of the agent. Requires action means, sorry, the agent cannot give you an answer. You need to do something on behalf of the agent. This was now a little bit of refactoring, so I will wait for a few moments so you can catch up. I will highlight the things that I did. In approximately line 129, you have to add the check for required actions. And then you have to add this switch statement and move the existing code into the completed case. Additionally, you have to add a requires action case. And there we are going to try to extract the function call and the parameters. That will probably be the last step that we manage to do today, but I think the rest should be pretty clear for you. Once we have the name of the function that we should call and the arguments, we can do whatever we want. Now we can call our internal entity framework library to store data in the database or whatever we want. I think that is what we try to achieve. When we achieve that, the rest is your job. Okay, so here, requires action. In the requires action, we need to get the run steps. Okay, so let's add a status message here. let's say run requires action, retrieving run details. Because there we will find the function name that we need to call. So let's get the run. Var run equals 2, and that should be get from JSON, threads, thread ID, run ID. I think that is good. Now let's analyze the data model. The function name is in run, required action, submit tool outputs, tool calls, and tool calls is a collection. This is a very interesting aspect. So ChatGPT is capable of telling us that we should not just call a single method, but it can tell us to call multiple functions at the same time. This is a super interesting and new feature here in the API. In the old API, ChatGPT was only capable of calling one method after the other. But now it can ask us to do certain things in parallel. Understand what I mean? So it will analyze the conversation, and if the conversation results in 2 function calls, it will not do the first one, wait to the second one, but it will tell us to call both functions at the same time. For us, for a simple example, we only have one function, so we simplify that a little bit, and we can simply go to the first one and use the function and the name here. In order to get rid of the warnings, we will add a question mark, so to make sure that nothing bad happens. Same is true for the arguments. Var function arguments, blah blah, we have here. And then we try to print everything on the screen. So let's say console write line, and the function name is this one. Oops, come on. The function name is this one, looks good. And the function arguments is this one. Okay, so let me check what my configuration currently is. Okay, the function is here, and the question that I sent is, I visited the family Müller in Linz in Dinghoferstraße 42, and I am currently on GPT 3.5. So I will try it now. I will try it on my side. We'll see. The system updates the assistant, creates the thread, sends the message, waiting for completed, and requires action, retrieving run details, and run details. Come on, I don't see run details. Did I do something wrong? Retrieving run details. Why doesn't it print? Okay, I have to debug something. This should work. I have to set a breakpoint here and run it in the debugger. No problem. Maybe I used something wrong here. Let's see. Okay, I don't need that breakpoint. Let's continue running it. In progress. Okay, here we are. So let's take a look at what we got. The run ID is set. The thread ID is set. So let's run this one. Okay, let's take a look at the run. Here, inside of the run, let's get rid of that one. Inside of the run, we have the required actions, submit tools output, tool calls. Here, function is the name store visit and the arguments. So why didn't it print it? Let's see. F10, function name. Oh, now it works. Maybe it was a temporary internet glitch, but it works like a charm. Take a look. Our GPT 3.5 model correctly extracted the town name, the street name, the house number, and it didn't even screw up the umlaut. I like that very much. And now comes the part where we need to do some code, where we need to do some work on our own. So here you would execute any business logic you want to execute. In this example, we just store the visit using EF core in the database. But please use your imagination here. You can do whatever you want. If you have a robot connected to your computer, you can move the robot arm depending on commands that you got in through spoken voice, for instance. You can do whatever you want. Now you have the AI assistant analyzing the intent of the user, and you can react on it. Got it? Please try it. I will give you a few moments to catch up and try whether it works as expected. I showed you the differences between 3.5 and 4. In 3.5, we would need to spend way more time to analyze whether the prompt leads to the expected result. This prompt that I wrote before is not capable of handling more complex scenarios where the user didn't enter a complete command. It immediately calls the function. It's too stupid to ask questions back to the user. But I think if you spend a little bit more time, you could make it with 3.5.2. But I consciously created this example in a way that you see that there is a huge difference between 3.5 and 4. Okay, the last step that is missing, and we will not find the time today to complete that one, is this last call where do we have it? I need to do it here. Let me show you that. Success. True. You can return any kind of JSON. It doesn't matter. Yeah, I have a timeout. So I need to clear that one and try it again. Come on. Okay. Cancel the run. Clear that one. So now I can try it again. Here we are. Run it. Okay. Let's submit the result. Success. True. Submitted. The last step that we will not make today is this one. Submit the function response. Once you executed the function, you need to inform the agent what the result of the function was. If it is a function that retrieves data, then it would be, for instance, the name of a customer or whatever you want to do, the temperature in a room. The AI will then take the result and generate a written response on top of the result. You could create a function which says get weather in city, and then you need to return the current temperature, the wind direction, the sun, and whatever. You can respond with whatever you want. So you need to use a post statement to post the result of the function to the agent. And based on that, the agent will respond with some text. The end user will never see this function call. This is a communication, a conversation that happens behind the scenes between your program and OpenAI. Got it? Good. Nice. Yeah, and then you can, of course, continue, create a loop on top of it, and I think you got the point. Nice. I am super happy that this worked out. I hope it was interesting for you to see how the API works. It was a pretty nice use case for REST APIs that is very relevant for your upcoming final exam. And I think with that, we can stop the coding, and maybe you can spend the last 10 minutes that we have discussing a little bit for possible use cases, or we will see. But that's it for the coding.